Hi, so today we're going to talk about the symmetry elements in a molecule Haem Porphyrin, which will appear here. So Haem Porphyrin looks quite complicated because there's lots of hydrogens, lots of double and single bonds. It looks quite kind of messy, but in reality it's a very, very symmetrical molecule, and that means that the symmetry elements are actually quite easy to understand. So looking at Haem Porphyrin, you can probably see, well, this molecule is basically a square shape, right, isn't it? And actually it's so symmetrical we can just say it's pretty much a square. And if I take something like this placemat, which is a square, and I attach these coins representing the nitrogens, then we can see all of the symmetry elements in Haem Porphyrin just from this simple model, okay, as I'll show you now. So let's think about this. So Haem Porphyrin is in the D4H point group. So we're going to have a C4 axis. Now that C4 axis comes out of the middle of this molecule through the iron out here, like this, and we can rotate around that. That's a C4 axis. That C4 axis also has a C2 axis coincident with the C4 axis, right? Coincident with it, so it's in the same axis, but we then are rotating not by 90 degrees, but by 180 degrees is one rotation. And we're also going to have other C2 axes. There's going to be a C2 axis that kind of cuts through each edge, like that, and a C2 axis that goes through the corners, like here and here, you see. So we have different kinds of C2 axis, three different kinds of C2 axis, one here, one like this, and one like this. Okay, that's it for rotations. Let's think about reflection symmetry. Okay, so in reflection symmetry we're going to have clearly a sigma H mirror plane in the plane of the molecule. Now the placemat here kind of breaks down because the placemat doesn't have cork and coins on this side as well, but if it did, you can imagine that there could be a mirror plane in the plane of the placemat, right? And that would be there in the molecule. There's a sigma H mirror plane. There's also sigma V and sigma D mirror planes. Okay, so the sigma V mirror plane bisects or cuts through the middle of the two atoms. That's going to come down here. There's a mirror plane in the plane of my hand here, like that. That's a mirror plane, and there's also one here as well. And then there's also a sigma D dihedral mirror plane, which kind of cuts through like here and here. So we've got the three different kinds of reflection symmetry we see in this molecule. We also have a centre of inversion, and that's quite easy to see because if I imagine my centre is here where the iron atom is in Haem Porphyrin, I can obviously invert this coin up to here, part of the middle doesn't change, there's centre of inversion. And finally we have an improper rotation axis. So an improper rotation or a rotation reflection axis is one where we rotate and then we reflect in a plane that's perpendicular to our rotation axis. So in this case we have an S4 improper rotation, S4 axis, and that happens to be coincident with the C4 axis. So if I have my C4 axis coming out of here, there's also an S4 axis there, and that means that I can rotate by 90 degrees because it's S4, and then I can reflect in a plane that's orthogonal to that axis. Okay, and the axis comes out here, the orthogonal plane is the plane of the molecule. Clearly in the molecule, if I reflect in that plane, nothing changes, right? That's a sigma H mirror plane. So we have an improper rotation axis as well. So hopefully you can see that even though it's quite a difficult looking molecule, we can exploit the fact it's highly symmetrical to actually make analysed symmetry elements quite straightforward.